uh, I read that you fell in love with the idea of space and space exploration when you were 5,
Mm.
watching Neil Armstrong walking on the moon. So let me ask you to look back at the historical context and impact of that. So the space race from 1957 to 1969 between the Soviet Union and the U.S. was in many ways epic. It was a rapid sequence of dramatic events. First satellite to space, first human to space, first spacewalk, first uncrewed landing on the moon, then some failures, explosions, deaths on both sides, actually, and then the first human walking on the moon. What are some of the more inspiring moments or insights you take away from that time, those few years, that just 12 years?
Well, I mean, there's so much inspiring there. One of the great things to take away from that, one of the great von Braun quotes is, "I have, I have come to use the word impossible with great caution."
Yes. Yeah. Yeah.
And so that's kind of the big story of Apollo is that things, going to the moon was literally an analogy that people used for something that's impossible. Oh yeah, you'll do that when men walk on the moon,
Yeah.
and of course it finally happened. So I think it was pulled forward in time because of the space race. I think with the geopolitical implications and how much resource was put into it. At the peak, that program was spending 2 or 3% of GDP on the Apollo program. So much resource that I think it was pulled forward in time. We kind of did it ahead of when we quote unquote should have done it.
Yeah.
And so in that way, it's also a technical marvel. I mean, it's truly incredible. It's it's the 20th century version of building the pyramids or something. It's an achievement that because it was pulled forward in time and because it did something that had previously been thought impossible, it rightly deserves its place as, in the pantheon of great human achievements.
And of course, you named the projects, the rockets that Blue Origin is working on after some of the folks involved.
Yeah.
I don't understand why I didn't say New Gagarin. Is that
There's an American bias
Oh,
in the naming. I
okay. This
apologize,
is very strange.
Lex.
Just asking for a friend.
I'm
Clarify.
a big fan of Gagarin's, though, and in fact, I think his first words in space, I think, are incredible. He purportedly said, "My God, it's blue," and that really drives home. No one had seen the Earth from space. No one knew that we were on this blue planet.
Yeah.
No one knew what it looked like from out there, and Gagarin was the first person to see it.
One of the things I think about is how dangerous those early days were for Gagarin, for Glenn, for everybody involved. Like how big of a risk they were all
They
taking.
were taking huge risks. I'm not sure what the Soviets thought about Gagarin's flight, but I think that the Americans thought that the Alan Shepard flight, the flight that New Shepard is named after, the first American in space, he went on his suborbital flight. They thought he had about a 75% chance of success.
Mhm.
So that's a pretty big risk, a 25% risk.
It's kind of interesting that Alan Shepard is not quite as famous as John Glenn. So for people who don't know, Alan Shepard is the first astronaut,
The first American in space.
American in suborbital flight.
Correct.
And then the first orbital flight is
Then John Glenn is the first American to orbit the Earth. By the way, I have the most charming, sweet, incredible letter from John Glenn, which I have framed and hang on my office wall,
What did you say?
where he tells me how grateful he is that we have named New Glenn after him. And he sent me that letter about a week before he died. And it's really an incredible. It's also a very funny letter. He's writing, and he says, this is a letter about New Glenn from the original Glenn, and he's got a great sense of humor, and he's very happy about it and grateful. It's very sweet.
Does he say P.S. don't mess this up, or is that
No, he doesn't.
make me look good?
He doesn't do that.
Okay.
But
All
wait,
right.
but John, wherever you are, we got you
All
covered.
right, good. So back to maybe the big picture of space. When you look up at the stars and think big, what do you hope is the future of humanity, hundreds, thousands of years from now, out in space?
I would love to see, a trillion humans living in the solar system. If we had 1 trillion humans, we would have at any given time 1,000 Mozarts and 1,000 Einsteins. That would our solar system would be full of life and intelligence and energy. And we can easily support a civilization that large with all of the resources in the solar system.
So what do you think that looks like? Giant space stations?
Yeah, the only way to get to that vision is with giant space stations. The planetary surfaces are just way too small. So you can, unless you turn them into giant space stations or something, but yeah, we will take materials from the moon and from near Earth objects and from the asteroid belt and so on, and we'll build giant O'Neill style colonies. And people will live in those. And they have a lot of advantages over planetary surfaces. You can spin them to get normal Earth gravity. You can put them where you want them. I think most people are going to want to live near Earth, not necessarily in Earth orbit, but in Earth, but near Earth vicinity orbits, and so they can move relatively quickly back and forth between their station and Earth. So I think a lot of people, especially in the early stages, are not going to want to give up Earth altogether.
They go to Earth for vacation.
Yeah. Same way that, you might go to Yellowstone National Park for vacation. People will, and people will get to choose whether they live on Earth or whether they live in space, but they'll be able to use much more energy and much more material resource in space than they would be able to use on Earth.
One of the interesting ideas you had is to move the heavy industry away from Earth. So people sometimes have this idea that somehow space exploration is in conflict with the celebration of the planet Earth, that we should focus on preserving Earth. And basically your idea is that space travel and space exploration is a way to preserve Earth.
Exactly. This planet, we've sent robotic probes to all the planets. We know that this is the good one.
Yeah. Not to play favorites or anything,
but Earth really is the good planet. It's it's amazing, the ecosystem we have here, all of the life and the lush the plant life and the water resources, everything. This planet is really extraordinary. And of course, we evolved on this planet, so of course it's perfect for us. But it's also perfect for all of the advanced life forms on this planet, all the animals and so on. And so this is a gem. We do need to take care of it. And as we enter the Anthropocene, as we humans have gotten so sophisticated and large and impactful, as we stride across this planet, it's that is going to, as we continue, we want to use a lot of energy. We want to use a lot of energy per capita. We've gotten amazing things. We don't want to go backwards. If you think about the good old days, they're mostly an illusion. Like in almost every way, life is better for almost everyone today than it was, say, 50 years ago or 100 years ago. We live better lives by and large than our grandparents did and then their grandparents did and so on. And you can see that in global illiteracy rates, global poverty rates, global infant mortality rates. Like almost any metric you choose, we're better off than we used to be. And we get, antibiotics and all kinds of life-saving medical care and so on and so on. And there's one thing that is moving backwards, and it's the natural world. So it is a fact that 500 years ago, pre-industrial age, the natural world was pristine. It was incredible. And we have traded some of that pristine beauty for all of these other gifts that we have as an advanced society. And we can have both. But to do that, we have to go to space. And all of this, really, the most fundamental measure is energy usage per capita. And when you look at, you do want to continue to use more and more energy. It is going to make your life better in so many ways, but that's not compatible ultimately with living on a finite planet. And so we have to go out into the solar system. And really, you could argue about when you have to do that, but you can't credibly argue about whether you have to do that.
Eventually, we have to do that.
Exactly.
So you don't often talk about it, but let me ask you on that topic about the Blue Ring and the orbital reef space infrastructure projects. What's your vision for these?
So Blue Ring is a very interesting spacecraft that is designed to take up to 3,000 kilograms of payload up to geosynchronous orbit or in lunar vicinity. It has two different kinds of propulsion. It has chemical propulsion and it has electric propulsion. And so you can use Blue Ring in a couple different ways. You can slowly move, let's say, up to geosynchronous orbit using electric propulsion. That might take 100 days or 150 days, depending on how much mass you're carrying. And reserve your chemical propulsion so that you can change orbits quickly in geosynchronous orbit. Or you can use the chemical propulsion first to quickly get up to geosynchronous and then use your electrical propulsion to slowly change your geosynchronous orbit. Blue Ring has a couple of interesting features. It provides a lot of services to these payloads. So the payload, it can be one large payload or it can be a number of small payloads. And it provides thermal management, it provides electric power, it provides compute, provides communications. And so when you design a payload for Blue Ring, you don't have to figure out all of those things on your own. So kind of radiation tolerant compute is a complicated thing to do. And so we have an unusually large amount of radiation tolerant compute on board Blue Ring, and your payload can just use that when it needs to. So it's it's sort of all these services. It's like a set of APIs. It's a little bit like Amazon Web Services, but for space payloads that need to move about in Earth vicinity or lunar vicinity.
AWSS. Okay, so compute in space. So you get a giant chemical rocket to get a payload out to orbit, and then you have these admins that show up. This Blue Ring thing that manages various things like compute.
Exactly, and it can also provide transportation and move you around to different orbits,
including humans. You think?
No, but Blue Ring is not designed to move humans around. It's designed to move payloads around. Okay. So we're also building a lunar lander, which is of course designed to land humans on the surface of the moon.
I'm going to ask you about that, but let me actually just step back to the old days. You were at Princeton with aspirations to be a theoretical physicist.
Yeah.
What attracted you to physics, and why did you change your mind and not become why you're not Jeff Bezos, the famous theoretical physicist?
So I loved physics, and I studied physics and computers.